What drives the movement of plates and pitches the carbon skyward? The forms obliterated in the process can't tell you. To find out, you have to dig deeper, to an even longer time scale, hundreds of millions of years.
Over the last several hundred million years, the continents that we know today have shifted and rearranged themselves like a jigsaw puzzle moving around on the planet.
Harold Tobin wants to know, what forces can move the continents?
It's a process of opening your eyes to what's on the planet all around you. You recognize when you look at a mountain, it's there as the result of a whole series of geological processes that operate over very long time scales.
To study those processes, Tobin has come to a ship off the coast of Japan, in waters where the shifting continental plates create a hotbed of earthquakes.
Chikyu is a deep ocean drilling ship that's designed completely for drilling for science. This is completely unique in the world. It's going to give us the capability to drill down into the earth to portions of the planet that we've never seen before.
Tobin and his team are here to dig into the planet's crust, 3 times deeper than scientists have ever reached before. Tobin is one of Chikyu's chief scientists, and he's here to give the ship its shakedown.
And that's for the first big drilling test. Come around. Yeah, you can tell us about current. This is the first time I've been to the ship in its complete state. And the technicians are getting trained up.
I'll show you the interesting bit of this.
Yes, check out these bits.
Right.
All right. Okay, so 3 kinds of drill bits here,
Yep.
right? So
Seismologists know only so much about what's going on at depth.
So over here we have the seabed, and you can see the fault zone again. We can look at faults on the surface, and we can look at seismographs. But earthquakes happen deep in the subsurface of the Earth. They take place several miles down. We want to drill in right here, right?
Now Chikyu is going to get to the bottom of that mystery.
To drill along that transect. Yeah, absolutely.
That's straightforward, yeah.
And in order to do that, we really need specialized technology that only exists in a few ships on the planet, and all the other ones are out there drilling for oil and gas. We're drilling for data.
Chikyu's goal?
To get samples of those fault zones themselves, to get the actual material that slips in the earthquake, and also to put instruments down in the hole so we can measure what would cause that earthquake to take place.
Down through a mile of open ocean, the bit will plunge. It will carve a tube through the sea floor, while the sediment released will be pumped to the surface to be studied. Chikyu will drill up to 4.5 miles through Earth's crust, straight to where the plates are actually colliding. All systems are go, but one test awaits.
Is the instrumentation on board the ship ready to go to do the kinds of measurements we need to do? Okay, so now we're starting to see the core display over here. Oh, yeah. They've done the first sampling of some core material at sea, real material that comes from offshore Japan, and now we've come out on board in order to see how we're going to make the cores flow through the laboratory. And what about this over here?
It's not only rock that Tobin will be looking for at depth.
When we think of the Earth's crust and the mantle, we think of heavy rocks, very dense materials.
But Tobin believes that it's 2 of the lightest elements that may actually power earthquakes: hydrogen and oxygen. Together, H2O.
Water exists as part of the crystalline structure of the rock itself. Those light elements, to a geologist, are the volatile elements. Water is the facilitator, the catalyst for the whole process.
This is what Tobin hopes to find in the samples he'll be collecting. He believes the smoking gun of earthquakes is water. It's what makes minerals unstable and fuels the motion of tectonic plates. When Earth was young, It was a mix of elements, evenly distributed. But most of the heavier elements, the metals, sank to the core. Under the crush of their own gravity and radioactive decay, they heated up to millions of degrees. The heat rose to the lighter elements above, roiling the minerals beneath the plates. The Earth's mantle became a cauldron.
Plate tectonics is a sort of a stirring of that pot. It's a way of remixing those things back together. You put a pot of oatmeal on the stove, you heat it up from the bottom, and you see the oatmeal kind of turning over in these boils. Well, that's what's going on in the Earth's mantle, of course, at a very, very slow motion kind of rate.
And where did Earth get the singular mix of chemicals that powers it? All the drilling in the world won't tell you.